Hello students, in this class we are going to see about the wave equation for progressive and stationary waves. First let us see about what is progressive and stationary wave, and after that we will see how can we derive the equation for the progressive and stationary waves. Let us see what is progressive wave. Progressive wave means a wave which is propagated in the medium without any changes in its amplitude. This wave is called as progressive wave. That is, we know how the wave is propagated in the wave is generated in the medium due to the simple harmonic motion of the particles. A wave is produced in the medium and it is propagated in the medium. So progressive means that during its propagation of a wave, there is no changes in its amplitude. That type of wave is called as progressive waves. Okay. Now we are going to see about the wave equation of a progressive wave. Okay. Imagine a progressive wave is traveled in the medium. The wave is traveled from left to right directions along the x-axis with wave velocity v, okay, small v. As wave proceeds, what happens? Due to the successive particle of the medium, vibration of the particle of the medium, the wave is propagated in the medium. So the displacement of the particle is given by the equation y is equal to a sine omega t. Is you all know this is the basic equation which is just studying from your basic classes. Y is equal to a sine omega t. You know omega is equal to 2 pi by t. So instead of omega, we are going to substitute the 2 pi by t. So then finally we will get the equation as y is equal to a sine 2 pi by capital T into small t. This is the wave displacement equation for the progressive waves. This is the waveform of the progressive wave. You know, the small y is the displacement of a particle from its mean position. So, if it is in the above, this is the crest upside அப்படின்னா we are representing the small y. If it is along side also, we are denoting the displacement as small y. Generally I specified as y here for upward, both upward and downward displacement. Okay. So here this particle initially the wave is started from this origin O, and again it due to the vibration of the successive particles it propagated in the medium. Consider another one particle at A. Okay, this point for assumption we are taking the particle at here A. Okay, the distance between the initial particle and the second particle is taken as small x. Okay, here the capital is denote the x-axis and the capital here I didn't specify, but here this is the y-axis. Okay, we all know the full waveform here. This is the full waveform, and the lambda denote the wavelength of the wave, progressive waves. This is the waveform of the progressive waves. So what is the displacement of the wave? Y is equal to a sine omega t. Instead of omega, we are substituting 2 pi by t. So consider a particle. You know, no, I already pointed you the particle at A. Initially, the starting point is denoted as O, and the next pass location is taken as capital A. Another one particle is taken as A. Consider particle A at a distance x from O. The waves would from O would reach this point at x by v seconds because the wave is traveled with a particular velocity small v. The particle A is at a distance x from O. So then there is the phase difference between O and A, that is called as x divided by v seconds. Okay. So this displacement of the particle after some time interval can be denoted as, instead of t we can write it as t minus x divided by v. So in the first equation you are substituting instead of t minus x divided by v. So finally we will get the equation y is equal to a sine 2 pi by t. within bracket t minus x divided by v. This equation can be simplified and it is also written in the form of y is equal to a sine 2 pi t. We are taking the small v outside within bracket vt minus x. Okay. Next one is properties of progressive waves. Instead of lambda TB, we are denoting it as lambda. So the lambda is equal to TB, you know, okay. This is the final equation of the progressive wave. You can write it either in this way or in that way. Whatever it may be, it's okay. But we have to, we are taking this very simplified form of the progressive wave. Y is equal to a sine 2 pi lambda Vt minus x. Okay. You all know what is a progressive wave having the same amplitude that is wave is propagated with the constant amplitude. Okay. Second point, keeping t constant, let x is increased by x then. Okay. So we are keeping the time, we does not vary the time, we are changing the distance of the particle. Initially we are taking the particle at a, somewhat we are taking consider the particle at a certain some other distance instead of x, we are in somewhat increasing the distance to x dash. Okay. So instead of x, instead of it is the distance x is increased by x dash. So x plus x dash. So y is equal to a sine 2 pi by lambda Vt minus x minus of 2 pi by lambda x dash. You are taking x dash equal to lambda. So instead of x dash, we are substituting lambda here. So lambda get cancelled. We will get the final form equal to y is equal to a sine 2 pi by lambda Vt minus x. This is similar to the wave equation. Y. So here we are if you are taking the x dash equal to lambda, we are proving the equation. Hence we can say lambda is known as the is lambda denote the wavelength of the wave. You are proving this equation displacement by considering lambda x dash equal to lambda. From this we can specify the lambda is known as the wavelength of the wavelength of the progressive wave. Okay. For the first point, we are keeping t constant and x is increasing to x dash. In the next point, we are keeping x constant and t is increased by t dash. We are substituting instead of t, we are substituting t plus t dash. We are simplifying the form. Instead of t dash, we are taking t dash equal to lambda divided by v. Okay, so we are substituting lambda divided by v. So everything it cancels. 2 pi by we are getting 2 pi sine of 2 pi is equal to 0 and finally we will get the same equation as the progressive wave equations. We are proving this equation if you are taking t dash equal to lambda divided by v. So from this we can say lambda divided by v is known as the periodic time of the wave. And next point, we are increasing the both the distance and time. T is increased to delta t and x is increased by v delta t. First thing, we are treating x as constant, t as constant and x is increased to x dash. The second point, x is constant and t is increased to t dash. For the next thing, for the third case, we are increasing both the t and x. Okay, substitute the t instead of t plus delta t and instead of x v plus delta t. Okay, so solving this we will get the final form as we are proving this equation again by taking delta t and v delta t. Thus in a time delta t the wave has at one unit distance v delta t. Hence v is known as the velocity of wave. From this equation we can say v is the velocity of the wave. So lambda is the wavelength of the wave, x divided by v t is known as the time period of the wave and v is the velocity of the wave. Okay. So we see up to now we see what is progressive wave and what is the waveform of the progressive wave and what is the general equation of the waveform, progressive wave and its properties. Okay. I suppose you all are clear about this. Next we will move on to stationary waves. So you know what is stationary wave? So here the two waves, two progressive wave. One is traveling towards from left to right. Another one is instant wave, or we can say one is instant wave. Another one is reflected wave. These instant wave and reflected wave overlap on each other or superimpose on each other. A standard waveform is produced. Okay, that wave is called as stationary wave. This in progressive wave means the wave is traveling in the medium. Okay, but in stationary wave there is no movement of the wave. It will remain stationary at its position. Okay, so how the wave is formed due to the overlap of two waves. What which two waves? One is instant wave, another one is reflected wave. Okay. So the form of a different formation of the stationary wave at different time intervals can is shown in the figure. The next slide. Let us see that this is the formation of the stationary wave at different time interval. Okay, at t is equal to 0, the two waves are in phase with each other. At t is equal to lambda divided by waveform is look like this. At t is equal to t divided by 2, t is equal to 3, t divided by 4. There is the phase difference between these two waves are like this. At t is equal to t, the same initial first case is repeated here. Okay, see at the different time interval how the waveform look like. At 2 t is equal to 0, two waves meet in opposite phase. At t is equal to t capital T divided by 4, each wave has advanced distance of lambda divided by 4. That is the phase difference between two waves is lambda divided by 4. At t is equal to t divided by 2, each wave is advanced distance of lambda divided by 2. At t is equal to 3t divided by 4, the wave has advanced distance of 3 lambda divided by 4, and in fifth case, the case 1, the first case is repeated here. Next one is properties of stationary waves. Concern here, this is the stationary wave is the super overlapping of two waves, overlapping of which two waves? Two progressive waves. So imagine first a wave is traveling, a progressive wave is travel from left to right along x-axis with the velocity v. The displacement is given as y is 1 equal to a sine 2 pi by lambda vt minus x. If the same is reflected back, if it travel from right to left means the instead of minus x we are taken as plus x because they are traveling in opposite direction. Okay, by the principle of resultant displacement is given the sum of the displacement. Resultant displacement is not the sum of y1 plus y2. So the sum of y1 plus y2 gives, sorry, I change over the slide. So y6 on the principle of superposition, the total displacement is equal to y1 plus y2. On simplifying, on applying the formula and on simplifying, we will get y is equal to 2a cos 2 pi x divided by lambda sine of 2 pi mu t divided by lambda. So this is the final form of stationary wave equation. Okay, y is equal to 2a cos 2 pi x divided by lambda sine of 2 pi mu t divided by lambda. So first thing, we are differentiating the above equation with respect to t. What it represents? dy by dt represent the particle velocity of the stationary wave. dy by dt equal to, on differentiating this, we will get 4a pi v divided by lambda cos of 2 pi x divided by lambda cos of 2 pi mu bt divided by lambda. Next one is, next equation is about the differentiating the equation with respect to x. We will get dy by dx equal to minus of 4a pi lambda sine of 2 pi x divided by lambda sine of 2 pi bt divided by lambda. Here dy by dx represent the strain of the waveform. Suppose you are all clear about this stationary wave. So what is stationary wave? How the waves are formed at different time interval, and what is the standard equation of the wave, and what is particle velocity of the wave, and what is the represents the strain of the wave. Okay. Next, we will see the what is the difference between the progressive and stationary wave. If you understand the difference between the two waves, you will be very clear about the progressive wave and stationary wave. Okay, so we know what that is the progressive wave mean. That is the advancement of wave in the medium. But in the stationary wave, there is no advancement of the wave. It will remain stationary at a particular position. Okay. So these waves are produced, that is progressive waves are produced due to the periodic vibration of the particles. Then the stationary waves are produced due to the waves form or produced due to the superposition or overlapping of two progressive waves in opposite direction. Okay. And third point, so here the each particle of the medium execute periodical motion about the mean position. So identical each here it executes a simple harmonic motion. So simple or vibration about its mean position. Each and every particle executes the same periodic motion about its mean position. There is no change in the movement of the particle when comparing each particles in the medium. Okay, all the particles are vibrated with the same periodic motion. The particle between two successive nodes are in same phase of vibration, while the particles at opposite nodes in the opposite phase of vibration, because in that the phase difference vary between the two successive nodes in the case of stationary waves. So the phase of vibration continuously vary from point to point, because for each point for a particular already we see in the case of your imagine a waveform of the progressive wave. Mm, there is a phase difference between the origin O and the A, no? So it is pointed out here. The phase of vibration varies from point to point. So the initial for imagine a particle O, A, B. So there is the phase difference between these three particles. Same point is repeated here. There is the phase difference between the two successive nodes varies with from next consecutive successive nodes. All, all particles do not pass through mean position and reach the do not pass through mean position reach the outermost position simultaneously. Here, all the particles pass the mean position or reach their outer position simultaneously, twice in a periodic time due to the movement of the node and antinode. So the particle pass through mean position twice in a periodic time. Here, the particle does not pass through its mean position. Wave. Here, the progressive wave curve advances without a change of shape. Here, the wave curve changes its shape from time to time. Because here we are specifying the nodes and antinodes, no? That's why. The amplitude of each particle is same, so the amplitude varies continuously from point to point. It is maximum at antinodes and minimum at the node. Here the progressive wave the amplitude is same, but in the stationary wave at the antinode region it is maximum and it is minimum at the nodal region. Okay. This we can conclude. So progressive wave means there is no change in the amplitude. So here the stationary wave, the amplitude is changes. Here the progressive means the S word itself denotes that is the progressive wave, that is the advancing of the wave in the medium. There is no advancement of the wave. This is the main difference between the progressive wave and the stationary waves. Okay, I'm sure that you are all clear about this waves and its wave equations. Okay, we will see the next topic in the next slides. Okay, thank you.